Exercise 2. What's the variable or parameter we are researching about? Remember that in this context we are defining parameter as a characteristic in a population, so the answer is customer satisfaction. You may wonder, is that the explanatory or the response variable? By now, neither, because this study is not about the relationship between two variables. This study is about the value of certain parameter in the population. Once we have determined the level of customer satisfaction, maybe we want to do another study to determine what is the relationship between the attention given by the employees and the customer satisfaction. In this other study, the quality of the attention could be the explanatory variable and the customer satisfaction could be the response. What's the population of this study? Interestingly, here I see wrong answers very often. Many students answer the 51,000 people that made credit card purchases. Not really. This study is about customer satisfaction in general, so the population is the set of all the clients of the store. The 51,000 that paid with credit card is what we called the sample frame. This answers question C. Question D. What is the sample? Here many students say the 1,500 customers that received the survey. I don't think so. Remember that the sample is what becomes the data. For those who did not answer, no data is generated. They might not even exist. They could have died years ago. So here the best answer is the 142 people that returned the survey. Do you think the sample will be representative of the population? Why or why not? Notice that this study is better designed than the one in the previous exercise. Here we pick the sample randomly. However, there are still serious problems in the study. Students usually point that those who pay in cash are not represented. This is perfectly true. They are not even in the sample frame. But it might not be a main problem if a wide majority pays with card. So what's the major problem here? The real problem is that by sending the survey through regular mail, they made it too difficult for the customers to answer. And there is no reward. So only a very special type of customer will answer and will be represented in the survey. What type of customer do you think has replied? Usually those with more free time and strong feelings. Usually negative feelings. Notice that only 142 out of 1,500 customers replied. This is a participation of 9.5%. It's ridiculous. This is still a strongly self-selected sample. If I was the owner of the shop, I wouldn't spend money, effort and time in a survey like this. If I am willing to accept a self-selected sample, I can just put a notebook in the exit of the shop for clients to write their comments, as many restaurants and hotels do. And if you really want a serious survey, what can you do to improve this? You can send the survey by mail, so they can answer it with the cell phone. You can give them a discount for the next time if they complete it, or you can administer the survey with a tablet or paper-based while they are paying. These are just ideas. Exercise 3. We want to pick a sample of students to administer a survey. Do you think either of the following sampling plans is most likely to avoid bias? If so, which one and why? Students are usually right that both methods are pretty fair. If the idea is guaranteeing that there is no bias in the sampling plan, the method that leaves the least room for bias is always the simple random sample. Since it is pure randomness, no one can say that it is intended to favor any kind of people. Systematic sampling usually means picking an individual every certain amount of them. It seems also pretty fair, but some students have objected that the last names that are more common, Smith for example, are more likely to be represented. If there are more than 20 Smiths In the college, one of them at least will be selected for sure. To the contrary, we more likely can skip all the Nguyen's or Garcias. You could make a case on this. I also heard one answer that is not great, but it's very interesting. Some students have pointed that if we pick every 20th student in a total of 3,872, we are picking at least 193 students. With the method in the right, we pick only 190. Therefore, the method in the left is better. This conclusion is incorrect. The sample size matters under equal conditions. Under equal conditions, the larger the sample, the better. But if the sampling plans are not the same, the sample size shall not be the main criteria to choose one method or another. If we agree that the systematic sample leaves more room for bias, these 3 additional students are not going to fix that. Exercise 4. In this exercise, we work with 3 common sampling plans. The idea of the simple random sample is that we have our population and we simply pick a number of individuals from it randomly. The idea of the cluster sample is that we have our population divided in categories or clusters, and we pick all individuals from a few clusters. For example, we select these 3 clusters randomly and we pick all the individuals that belong to them. I summarize it like this: all from a few clusters. The idea of the stratified sample is the opposite. We have our population divided in categories or strata, and we pick a few individuals from each category or stratum. For example, a few from here, a few from here, and so on. I summarize it like this: a few from all, or a few from every stratum. Here we select 30 seniors from each high school, so this is stratified. Here we select all the seniors from only 3 high schools, so this is cluster. Here we select 500 seniors from the whole population, so this is simple random sample. In this context, which method is most likely to include bias? The cluster sample, because only 3 of the 12 high schools will be represented. So when do we use a cluster sample? Usually when there are good reasons to think that the clusters are similar to each other. For example, a professor is teaching 3 or 4 groups. If the professor is to be evaluated, usually the university prefers a cluster sample. The college picks 1 or 2 of those groups and passes a survey to all the students there. Some groups will not be surveyed, but this is not problematic because the professor is the same, so there are reasons to think that the quality of the teaching is going to be similar in all the groups. On the other hand, the students' satisfaction will likely change depending on the type of student. By picking a whole group or 2 whole groups, the college guarantees that all that diversity of students is represented in the sample, which is not guaranteed if we pick a few students from each group in a stratified sample. In this exercise, we note that high schools tend to change a lot depending on the neighborhood, especially in a city so diverse as Los Angeles. So a cluster sample would not be a good idea. As an example of a stratified sample, I usually mention the Congress. We have a population, that's the country, divided in states, and we make sure that a few representatives are selected from each state. There are 2 versions of this commonly used in statistics. Sometimes the amount of individuals that we pick from each category is proportional to the size of the category, which is done in the House of Representatives. And sometimes the amount is independent of the size of the category. That's the idea of the Senate. For every category, 2 senators are selected. The paramount difference here is that the concept of statistical representativeness usually has to do with randomness, while the concept of political representativeness has to do with democratic elections. Senators and representatives are selected by a democratic procedure, not randomly. As a final thought, in this example of the high schools, what sampling plan do you think would be better? The simple random sample or the stratified sample? It's difficult to answer. It depends on what we want to do with the data. At the first sight, I would say that the stratified sample, because of what I said, that high schools may vary a lot from neighborhood to neighborhood. With a stratified sample, we guarantee that all this variety is represented.